you're talking about legionellosis, I think it's more what I was talking about before, some kind of a standard for the infrastructure necessary for water treatment. And maybe we need there's all kinds of chemistry you can use on water treatment. I mean, it's much more of it's a matter of, okay, well, this is a process for identifying your risk and quantifying it, and then deciding what you're going to do about it, which is huge.
I love talking to Craig. He's got these great prosaic metaphors, carving a statue out of fog. Look, guys, I know Larry's got to hit the dusty trail, and I wanted to point out, just for our record of work here, this is our markup of the legionellosis standard. I pointed out points on this particular, points on this document where we might make some statements about the product itself. So we'll have a breakout meeting on it. So we have marked this up. And more importantly, I probably should say that we have Larry Spielvogel on the phone. We have, obviously, we have a new person, another mechanical engineer, Adam Keppa, who we hope will be working on the eyewash stand. When I said eyewash, he came over, and of course myself and Craig Butcher. So the gist of this is that our next steps on this is we'll probably be approaching a couple of manufacturers. It'll be Marley and Baltimore Aircoil, and we'll start to get their technical staff in here to explain to us. And what I'm trying to show here, Craig, why don't you show me where you thought, this is your pointer here, you can see where the red.
Well, I'm looking at this cutaway sales presentation, right? So you can see this area here, right? This fill extends all the way to the bottom of the tower. I'll pretty much guarantee it, right? And so what happens is the material comes in there and this loads up. And then probably some other person has decided they didn't want to have any noise, or they stuck a wall right in front of it or something like that so nobody could see it, and you can't get at it, right? But you have to get up there and get in here and physically remove this stuff, right, from this side, and that can be a real pain. Another thing I was going to observe was this. You see this little area here? So there's our cold water return. That's going to, underneath that, they've got a bunch of piping. And the piping underneath is at least as much of the problem as anything else. We find out we might have 5 or 6 of these cells all together, say, and then somebody's got an equalizer line in between them. And the line may not ever have a drain. It might have valves in it that are situated with the dang stems pointing vertically, so you can't close the stupa, or you can't close it once, but after the dirt gets in the bottom of it, the valve never seals off. So now you can't isolate the tower to clean it, and you can't get the crap out of the equalizer line because there's nowhere for it to go, so it just builds up. Okay. Down in here, you can't get at this because you've got this other structure stuff in the way. I've got this in the way, so you got to get in there, and it's
not
hard.
An easy thing to maintain.
Yes, yeah, okay. It's not impossible, but it's not easy.
Okay, so Larry's assertion is
we
need to look at the water treatment part of it, and we're saying we don't deny that.
Yes.
But if we're talking about trying to bang about 20% less off the risk, we think a combination of water treatment, but also trying to keep the hazard from growing to begin with. Go ahead, Larry, your statement on water treatment.
You there?
Oh, looks like we lost him.
He hooked off.
Okay, all right.
So anyway,
okay.
I have to disagree with him about, well, dirt isn't really a big problem. Well, he's the engineer who designs it. Mm-hmm. I'm the poor son of a bitch who, for some period in my life, was actually fighting the dirt, right? Right.
Yeah.
And it's and it isn't his fault. I'm not saying that.
Yeah.
But we all know, we see based on what we have seen in the past, right?
Oh, no, you're right.
And he is right. There's no way that. But the point is, if you had that, so look at that. Go back to that picture if you can. And again, I'm just ranting here. But if you take,
here's your.
So imagine this. Here is this thing, but usually that's connected directly to a pipe, right? There's usually no. If all the dirt goes into here, right? If there were an actual catchment arrangement under here, where the material falls into the thing, and then the water can slow down and then come back out, right? Mm-hmm. You're going to have that's a catchment, right? We do it in the streets out here, mm-hmm. Mm-hmm. And a lot more of the garbage, right? And then if this were actually. This isn't really slanted, at least not very far, right? Mm-hmm. So the washing thing. I've seen manufacturers, they do sell things like, for example, you might have a pump under here, and you got to do this later on. You got to do it yourself. Mm-hmm. And then they take a thing, and sometimes they have these little. I've seen somewhere you have you have a manifold, and you've got these little flexible hoses that come off of there, right? right? So if you take a garden hose and you run it, and you've seen it whipping around. So I've seen one design. It's pretty cool. It has these little whip things, and they just constantly do this, and they are constantly washing that material, so you get this flow right at the bottom of the basin, which is driving all that garbage to here.
So it's just less place for
the solids to
for
stand.
this biohazard to
Right.
grow. Right.
Once you have a layer of granular or other material, and there's all kinds of stuff in there. There's going to be chips from the pipes that have flaked off. There's going to be pieces of birds. I mean, when you turn on a cooling tower, sometimes I've actually had raining pigeons. It's kind of grotesque, where the pigeons are inside. You turn on the tower, the pigeons suddenly are alarmed and they fly up through the fan, and then the next thing you've got is something you don't want to talk about at a wedding.
Okay, well, I know that.
So what happens? So all that stuff is in there. So if you can wash this clear into this trough, that by itself is already an improvement. And then if you can have this stuff run down to something else, and if you had a catchment so that most of it didn't get into the main piping and move on, so once it gets in here, I mean, you might have 2,600, 3,000 gallons a minute, right, in a pipe that's this big. Because the pipe is sized, guess what? To optimize the flow and so forth considerations. It goes right to there. All that crap that gets into the pipe, that's going to move, right? It's going to move, and where it's going to go? Down to the chiller. If it it'll may wind up in some of the pipes, and if you have a vertical trap, you get that. But what we also find is the equalizer piping loads up all the time, and you almost never have maybe you'll have on that pipe, you might have a 1/2 inch or a 3/4 inch drain, that diameter. Mm-hmm. Sometimes you might get 1.5 inches. Even that requires an awful lot of water to flush that stuff through. Mm-hmm. So I've got equalizer lines that, we've seen equalizer lines where the system won't even equalize it because over the years you've accumulated enough stuff and you can't get it out. And there's not even a blind flange on the end or something that you can readily service to do that ordinary cleaning. So stuff like that does matter.
Well, I'm a great believer in accumulation of marginal gains. So the combination of the water treatment, and as I see the standard, so you've given us a fairly good idea of what a product improvement might look like. Yeah. I hear 3 or 4 good ideas from this one perspective. And of course we know that, and if I get back to our document here, we know that a lot of it is water treatment. So there's a fair amount of this document is water treatment. And our markups, we're focusing, frankly, we believe that there'll be so many chemical manufacturers advocating for selling more chemicals, and we're not going to approach that. So we'll go with the more difficult work is trying to get the manufacturers to innovate on their product. So that's the tack I've taken. I don't know if we have any more resources, advocacy resources to do much more. So my next steps will be to get these guys on the horn and to let them explain what might be possible. I think if we're spending, we're probably buying somewhere between 1 to 10. We're probably buying and maintaining something on the order of $10 billion of cooling towers in our industry. We have a $300 billion industry. I'm going to bet that it's somewhere in that order of magnitude, and I think that that's enough of a market that he might think about it. So we'll start to raise the level of debate on that and get them in here post haste. We will then prepare some statements, and likely what I like to do is just to get something on paper. Where's our friend here? We're just going to get something on paper. This is not what ASHRAE calls what it is called a continuous maintenance document. ASHRAE 90.1, as I've tried to point out over here, is a document that changes pretty much every 30 days. Not many people know of that. So, for example, this is the monthly meeting.
This is supposed to be 90.1?
No. This is we're doing a range of issues, and we frankly run out of time. It's not uncommon. So we're dealing with the one that seems to have the highest profile and seems to be filling most of the conference. The conferences has to do with this one. So we're going to that's our next step here. So since Adam is here, I wanted to give an update on the eyewash standard, and that was on the agenda for today. We know that Rich will be approaching APA. This was identified as an APA priority back when was this, November 2013. As you know, that we did have one of our professors prepare a report, and the committee did not accept our data they felt, oh, excuse me, they did accept the data, but as I recall, they felt that, maybe you might have been right about the water quality. Once again, we get back to incoming water quality. But they said that they fail so often that we still need to test them every week.
Every week?
Every week.
Well, I guarantee you.
But remember, this is a recording.
That's a very challenging schedule.
That's right. Yeah, okay. So we believe that at least it could be scalable according to the occupancy. And we even made some proposals that if the eyewash, if the occupancy is not here, if the work that's going on has ceased to exist in that building, then you still don't have to test the eyewash solution. Which seems to us intuitively obvious, but some of the standards process allows, and this is a case of manufacturers being the authors of the standard, manufacturers, and they're always invited to these meetings, by the way. So they have to explain to us why this is shifting risk away from them and more upon us. I think it's fair to say that there's a lot of field installation, and you can some of your own thoughts on this eyewash standard might be helpful. I should shut up since you were on the front line of the study. But our position has been we're respectful of the need for testing. The difficulty we have is that every safety technology has a group of partisans that think there is the only risk. And people like my boss and others like him in this industry saying, I'm looking at a standard here. I can afford to conform to everything. And all of this kind of looks like market making or shifting of risk. Notice that ASHRAE 188 is a risk standard, right?
Risk management standard.
Risk management standard.
It does not specify that. It does not provide anything that tells you if you do this, right, you're home clear, right? You've met requirements.
Okay, so this here, when you say risk management standard, so it's probably fair to say that people in the front line of this are not people that understand the technology as well as you do, so they're using the only tools they have, which is legal tools and standards and all that stuff. So we understand that. We run across that. We're a $300 billion industry, as I will remind the manufacturers. That's twice the size of General Electric. Let me repeat that. Our industry is twice the size of General Electric, and we certainly have the market footprint to try to have some influence, but I don't underestimate the political influences that would go into a document like this. Our concern is that we optimize safety across a whole range of risks, and this is just one of them. And then we're going to use our expertise. Remember, we have legal expertise also, but we're going to use our expertise to try to get what I'll call a technical solution, and thereafter, if it's necessary, a standard solution. That would mean that once we have some parameters here that all the manufacturers can agree upon, then we would simply make a standard which would say you will have a robust pumping of solids or some way for it to drain here, so that we can take that 3-day takedown period down to 2 days, and then it's more affordable to go in there more frequently. So that's it. All right, I'm going to stop the recording. We're all running out of time. We're about 10 minutes over. And so my colleagues on this call, we will record this. It is recorded. We'll upload this in a few days, and we will set a time for next month. Remember, everyone, that we're having Joe Bhatia here. We're having Joe Bhatia here next Friday. You're welcome. We have a live stream here. If you're anywhere else in the world, you're welcome to call into our Ross School of Business, and you will be able to see the presentation in its entirety anywhere on Earth. So we think it's that important. It is that important to us, and I'm grateful for your time.